Alright, ladies and gentlemen, this is going to be a video that is focused primarily on the inheritance portion of the lesson. I do have this form here. I'm just going to go over it very quickly. Basically, it's just our basic form here. We have a basic information that has first name, last name, and age. Some student information, which is major GPA, teacher information, which is expertise in the years of teaching. We have two radio buttons, student and teacher. Student, of course, refers to this. Teacher's information records that, of course. The show button is going to create an object based on the information we've put in here, and then just display it to this. It's a rich text box, but I'm going to call it a label. Reset is going to clear all the fields and set the person type back to student, and then the exit button, of course, is going to close the form. So I'm going to go ahead and just kind of run this real quick just so you can see what it does. One of the other things that this does is whenever you switch from student to teacher, it clears out all of those text boxes and then disables the text box that or the group that is not applicable. So for instance, let me just go ahead and type in some basic information here. So if I put in my major as computer science with a GPA of 1.23, whenever I click over to student, it's going to disable the student box information here, and it's going to clear it all out. And it's going to go ahead and put the information, or the enabling is going to be over here. So just like that. I could probably make a small adjustment to this to adjust the focus as well, but that's fine. My expertise is in computers, and I've been teaching for 100 years. Whenever I switch back to student, it empties everything again, and so on and so forth. Right now, I do have some basic information set up in the show. I think it just takes the information from the first name, last name, and age and displays it as a person, and I can reset it and I can exit it. So let's just try it real quick. We're going to show, yep, name is GM, age is 12. I am older than 12. I don't want anybody to think that I'm not. Because I'm online, I have to be older than 12. And of course, reset. Ask if you want to reset. You click yes. And if you want to go ahead and exit, you click exit or hit the escape key. And it's going to tell you, ask you if you want to exit. You hit yes. So that's the basics of the form. It's really just about anything, just like similar to what we've made several times so far. We'll just take a real quick peek at the code. I'll come back to this line in just a minute, but basically we have our code. We have a reset form method, which is one that I always code into my forms. This clear additional info just clears the text boxes for the two groups, the student and the teacher groups. That's my validation method. I'll come back to that in just a second. Button exit checks to make sure you want to exit. Form load resets the form. Button reset calls the reset form method if you want. Button show, so this is it. It checks to see if you have valid data. Gets the information from the form, first name, last name, and age, and then creates a person based on that information. We've done all this before, it's nothing new, and then just calls the display person method of that person. It does catch some exceptions if we need to. And then, of course, the rad teacher and rad checked. And I will go ahead and I will do txt major dot focus and txt expertise dot focus. So that'll just put the cursor where I want it to be. When we click on those checkboxes, let me just see if I do reset form. Yeah, reset form. Okay, so that should work just fine the way I want it to. So that's pretty much it for how the basic form is set up. As far as the person class, it's a very basic setup. I have my first name, last name, and age. I have a person. I have my person constructor that accepts the first name, last name, and age as strings and an integer. And then I have my public getters and setters. I do have an exception if someone tries to enter an age less than 0. And then my display person, which just literally shows the name of the person and their age. And that's all very, very basic stuff. The other things that I have created so far in this project is I have created a student class and a teacher class. Eventually I'm going to get to the point where these actually inherit the properties of person, but I just wanted to get through the basics of what all this is doing for now before I got to the before I get to the real meat uh, of the presentation here. So the last thing I'm going to discuss real quick, and this doesn't have to do with inheritance per se, but it is something that we can use to kind of make things a little bit easier in our programs. So I've added one additional line up here to our using statements. It says using static inheritance dot validator. Now I did bring in let me go ahead and pull this up. I did bring in the validator class from the previous assignments and stuff like that. So we have this validator class available to us to use for validating our code and stuff like that, or our inputs. Whenever we do this and we say using static inheritance validator with a dot in there, what it's going to do is it's going to bring in all of the information from that validator class and kind of prepend all of the methods that we get there automatically with this validator. So if you remember when we used this before, and if you've looked in the text, you'll see this. He has validator dot is present, validator dot is present. Whenever we use the using statement up here like this, we no longer have to use validator dot each time that we use that one of the methods in that class. Now, it's important whenever we do this that we don't unintentionally do something that we don't want to change. So for instance, let me just find a method that we might use. So like initialize component. If we had something in validator that was called initialize component, we would want to make sure that we specify whether we're using the initialize component of the form or the initialize component of the validator. Otherwise, C# is going to get very, very confused, and we very, very likely could have some unintended consequences with that. So it's just important to know which items you're using. The validator class doesn't have any methods in it that I can remember that interact with other methods that we use. So we have the is present, the is int32, is valid email is in there, is decimal is in there. We'll be using is decimal here in a little bit. And stuff like that. All of those things are in there. None of those exist in C# by itself. So I feel pretty confident in saying I can import this import this validator class and use it this way without having to specify that I want the isPresent method of the validator class every time that I use it. Saves me some keystrokes, saves me some space in my programs. Something that is completely optional for you to use if you want to. I don't even know if it's covered in the text later on, but it is. I'll just cover it here. If you want to use it, you can. Okay, so moving on. I think so far we understand what we should understand, hopefully, what's going on in this form and what's going on in the person class. This is stuff that we've been covering for the last couple of weeks, and I feel like we should be at the point where hopefully we're starting to get this information down. So the next one I'm going to look at is the student class, because this is going to be my first actual foray, 9 minutes into this inheritance video. This is going to be my first actual foray in this video into actual inheritance for the sake of for the lecture here. So what inheritance is it is often defined as a relationship. And so what that means is when you inherit something, now I often use the terms child class and parent class. You could also use the terms subclass and superclass, or another one that is often used is base class and inheriting class. I'm going to use child class most likely. as my descriptor for it just because it makes the most sense in my head that the children inherit stuff from their parents. So I have blue eyes is because my dad had blue eyes, or has blue eyes, and I inherited my blue eyes from my father. My daughter has blue eyes because she inherited her blue eyes from myself and my wife. So that is how inheritance works. It is also how inheritance works within programming, by and large. So whenever we say the idea of inheritance is a relationship, is in quotation marks, we're saying that when we inherit something. So when the student class is going to inherit the person class, we're saying that a student is a person. So I hope that kind of makes sense on how that works, because that is the basis of all inheritance. Every student is a person, at least with regards to this program that we're getting ready to write. So when we actually want to inherit something from another class or inherit another class in C#, we come up to our class header here and we put a colon after the name, and then we put in the class that we want to inherit. And we're going to inherit the person class. Now, by and large, the class that we're inheriting has to be a part of the namespace that we're working with, or we have to have a using statement that pulls in that information or something. But by and large, the inherited class, the parent class, has to be something within the namespace. And ours is because we have built this namespace from scratch, so we have this inheritance namespace spelled incorrectly, but that's my fault. That contains a person class, and we're going to inherit everything from that person class into the student class. So what that means is this student class already has the first name, the last name, and the age that we get from the person class. It also has the display person. I think it's called display person. Let me just make sure. Yeah, it also has the display person method that we get from the person class, and we do not have to redefine those. However, I will tell you here in a little bit that we're going to redefine at least the display person method, because right now the display person method only displays the first name, last name, and age. It's not going to display the major, it's not going to display the GPA, and we want all of those things to be displayed. So now we have inherited the person. So this student now has the first name, the last name, the age, and the display person methods. We do not have to redefine those. So I don't have to come down here and say public string first name get return this underscore first name and set this dot first name is value. And you'll actually see that whenever I try to do this, I can't do it because I don't have a first name. You also see that there's a green squiggly here because this is actually hiding a property that I already have. So unless I want to override this or overwrite it, I don't have to do it. And because C# or Visual Studio here is actually telling me, don't do this because you already have it defined. You already have this in person, so you don't need to redo it. Now, could we? Yes, sure, there are ways that we can do it, and I'm going to cover that in just a minute. The other thing that you'll notice here is there's a red squiggly under the underscore first name. And if I move my head real quick, let me go and just do this. It says the person underscore first name is inaccessible due to this protection level, or due to its protection level. So if we remember, in the person class, the first name, last name, and age are all private. That means we cannot access them. We cannot access those properties of the person class from the subclass, from the child class. So we could redefine a private string first name here. We could redefine that, and we'd have a whole new first name property specifically for the student, but we don't need to. So we can just remove that altogether, and we can remove this altogether because we don't need to redefine those things. There are a couple of things that we are going to want to redefine though, or to define though, and one of those is going to be a constructor that we can use to not only create a student, but also fill in the information about the person. So the long way to do this is we could say we want to take in the string first name, string last name, int age, string major, and what I got, decimal GPA. Now I could write this, and I could say this dot first name is first name, and so on and so forth. I could do that for last name, for age, major, and GPA. However, because I have extended, or because I have inherited the person class, I have also inherited the person constructor. And that means that we can already create the person portion of this student by just calling the constructor of our base class and passing in the first name, last name, and age. When we call in this, we have a colon here, and then we have the base, first name, last name, and age. We are going to call in the parent constructor for the base class, which is person, that accepts two strings and an integer, which is this one. And that one is going to set the first name, last name, and age for us. Then we don't have to do this anymore, but we do still have to do the major, and this dot GPA is the GPA. And now, and of course, you'll notice I do have an argument exception there for too low or too high of a GPA. But that is how we're going to create a constructor for our student class that calls the constructor for our base class and then fills in the rest of the information. And I'm going to go ahead and do it up here too, just because I think it's generally considered a good programming practice that when you call a default constructor for something like a child class like this, that you also go ahead and call the parent class. It's not necessary, and actually in some instances it won't be, you probably shouldn't do it. And I'll give you one instance real quick. When we create our new form, we create a form that inherits a form that we get from system.windows.forms. So this form is a class that has a definition, and we inherit, or we are creating a form1 child class or subclass from the form parent class, but we do not call the form constructor in our constructor here. It's just something that we don't do. And it's very possible that form may be an abstract class, I'm not sure. Which means that we could not inherit it, and I will cover that later on in this video. But form1, we have a constructor here for form1. We do not call the constructor for form. So that's just something to kind of keep in mind. So, you know, that's all fine and dandy. We now have our constructor. We have a constructor that calls the parent constructor, and now we're going to have a student that's going to have a major and a GPA. And I'm going to go back to this real quick, and we're just going to go ahead and instead of creating a person here, let me go ahead and create a student as a new student. And student requires 2 more parameters, so we're just going to say CS and GPA is 1.23. 0.123, I did it really well, 1.23. M, because it's a decimal. And this is just information I'm going to fill in there, so I don't have to worry about continuously typing all the time. Let me actually go ahead and do one thing real quick. We're going to just add some default text to my properties. So first name is going to be Greg. Last name is going to be Morris. Age is going to be 27. Okay, so those are going to be some default values that are going to be in my form. Let me get back to this view. So those are just some default values that could be in my form. So whenever I run this, I don't have to type them in every time, since I am getting the information from the form to create my person. So I'm going to go ahead and run this again now. Waiting. Okay. It didn't even put the information. Oh, because I have the clear form as the first thing in there. Okay, that makes sense. Okay. So I'm going to do this now. I'm not going to put anything in major and GPA yet because I haven't done anything. I'm not getting any information from those yet. And I'm not doing any conversions or anything or any validation on it. So it's going to go ahead and take the first name, last name, and age from the form, convert those as appropriate, and then it's going to display the person. And it still says Greg Morris, age 27. Now the reason for that is because as I come in here and as I look at this, I'm calling the display person of the student class, but I haven't defined the display person of the student class yet. So it's still going to use the display person of the person class. So the next thing that we're going to work on is defining the display person of the student class and what we can do with that. So when we want to override the display person method, we do really want to name it display person. And the reason for that is when we start working with classes and objects and inheritance and stuff like that, we really want to make sure that we're using the same method names that do the same thing. And there are some reasons for that, and I'll demonstrate that in just a minute. But first we're going to go ahead and we're going to whoops, caps lock is on. We're going to go ahead and we're going to create a public string called display person, and we're going to return string.format name, keep hitting the caps lock, name, age, and because we are dealing with a student, we're going to display the major. Okay, hold on, I got my numbering wrong here. That's 2. Major, and then the GPA, and we're going to display this dot first name. I'm going to put these on new lines. This dot first name, this dot last name, this dot age, this dot major, this dot GPA, and we will do toString rounding to there, rounding to 2 spots. So there's our display person. Now everything looks like it should, but we are getting this green squiggly line here. And once again, it says this hides an inherited member person display person. Use the new keyword if hiding was intended. Well, it's not really intended. I'm not really trying to hide the previous method at this point. I'm just trying to redo it. So the way that we redo things is to override them. So we put in the keyword override, and now we have this issue that pops up that says that display person is not really set to be overridden, because in person display person is not set to be virtual, abstract, or overridden itself. So what we need to do is we need to come back to the person class, and we need to set it up that it can be overridden. And we do that by the keyword virtual. And virtual allows us to call the display person here, and it also allows us to override it in a subclass. But now that we've overridden it, we can actually use some of the information that we get from the original class. So what we can do is we can call that base class again, and the base class has a display person method that is going to return the name and age of the person, and then we're going to concatenate that with the string.format. And since we already have the name and age from the from the base class, we can remove those and we can remove those. And then we just need to switch this to 0 and 1. And now we have a display person that's going to call on the name and age from person, name and age, and then it's going to concatenate the major and GPA on the end of that. So let's go ahead and run this again real quick. And we will go ahead and just fill in some basic information real quick. So we're going to do Greg Morris. My age will be 27. Major is computer science, and my GPA is 1.23. I had a much better GPA, by the way. I just want you all to know that. And we're going to go ahead and show that. And now we have the name, the age, the major, and the GPA all in one output. And it works well together because we've created a student, and that student has specific information that is essential to it as a student. So I hope that kind of makes sense on how we override things. The other thing that I'm going to cover real quickly is other methods that are already built into the object class of C# that we can also override. Now the text briefly touches on this, but it doesn't really go into much depth, so I really kind of want to showcase one that whenever I was doing application development, would override regularly and use in a lot of my programs. And that is the toString method. So one thing that you probably maybe have noticed before is whenever we do things like work with decimals and things like that, we call this toString method. Well, if we use the toString method now, which does exist to every object out there, and you know, I'm just going to go ahead and I'm going to add it to the end. So let me add some to display person here. We're going to add another line break there. And then I'm going to go ahead and say lb output, dot text. And I just want to go ahead and add toString. So I'm going to display the person like normal, and then I'm going to display what happens whenever I hit the toString method of my object. So again, we're going to do Greg Morris, 12, major, and we'll show that. And now whenever I do that, I have my name, my age, my major, and my GPA, and then I have this inheritance.student at the bottom. So inheritance.student is the namespace and the class that this belongs to. So we know we have the right class. At least that's a good thing. But that doesn't really tell us anything. So if I was trying to create a log file based off this toString, or if I was trying to create some other type of output based on the toString, it's not giving me a lot other than what class I have used. So what I want to do is I want to override the toString method like that. And if I do this right now, it's going to return the base toString. Well, the base.toString method is just that inheritance.student is all I'm going to get, or inheritance.person is all I'm going to get. So I really don't want to do that. So what I want to do is I actually want to return string.format, and then I'm actually going to use this to create a comma-separated value sheet, or a CSV file. So I've created this string that's going to have the first name, the last name, and the age, and they're just going to be separated by commas. And then in the student class, I want to further override that to make sure that I get the additional information from overrider, from the base class, but also from the student class. Now here, I can actually return base.toString because the base of this class is the person class. And if I hover over that, it actually tells me that. Class inheritance person. If I come over here and if I were to say return base.toString, the base here is the system class, or the object class, the class object. Object class is what I'm overriding, or is what the base is. So I don't want to return that. But whenever I work with a student, I can return this base because this is going to give me the first name, last name, and age separated by commas. And then all I really want to do from here is I want to do string.format, and I'm going to put comma 0, comma 1, this dot major, this dot GPA dot toString F2. Now, I am putting the comma here first, and the reason for that is because the base class, this class here, doesn't end in a comma. So if I don't put anything first in the next, whenever I call this one, I'm really just going to get the age, and then it's going to be run right into the major. So it's going to be Greg Morris, 12 CS, all in one. So I want to make sure I put this comma here because that's going to separate the 12 and the CS. And then I put a comma before my GPA, which I'm going to round off to 2 decimal places. So now I have a toString method that actually works for the information that I want. So let me go ahead and run this one more time just to showcase what the toString method is doing, and just to showcase that I am getting everything that I want from here. So we have Greg Morris, 27, major CS, GPA is 1.23455. So just to showcase that this is going to round down to the 2 decimal spots, my age is going to be there and everything like that. So there we go. I have name, Greg Morris, age 27, major CS, GPA is 123, and then I have the CSV version of that, which is Greg, comma Morris, comma 27, comma CS, comma 1.23. I could set this up to where the toString prints out 3 places. That would be just fine. It's however I would want to do it. But that all comes from this toString method, which I have overridden in the subclasses. So that's pretty much the basis of overriding, and this is pretty much the end of the student class, because I think I've pretty much covered everything that we need here for this. So the next thing I wanted to kind of showcase was what we can do with the teacher class, which again, very, very basic in its premise, but there's a couple things that I wanted to do with this one specifically that I'm not going to be doing with the student class, and I think you'll see why when I get there. So the next thing we're going to do is look at start building out this teacher class the way that we want. Most of it is already set up with the very basics. I suppose I could come down here. I'm just going to copy the display person and the toString methods, and I'll go ahead and I'll just paste those down here because we're going to be using them. Right now I'm getting red squigglies. We'll fix that in just a minute. So we have that information now. Now we can go ahead and start the inheritance process. So the first thing, again, that we need to do is go ahead and call, or to inherit the person class. And that actually takes care of most of our red lines. The only difference is now we have major and GPA, which is, for this one is expertise and years. I'm going to remove this because years is an integer, so it doesn't really need to be rounded to anything. And expertise. And we're at a place now where this would actually work for the most part, with the exception of I want to make sure that I call in the constructors and build my constructors. So this won't take but a minute, but it's the exact same process as before. We're going to take in the first name, last name, age, string is expertise, and the what's the last name? Years is an integer. Like that. Go ahead and call in my base constructor for first name, last name, and age. Okay. And then this dot expertise is expertise, and this dot years is years. Okay, so we now have our teacher. We can come back to the form. Oh, that's right, I didn't get that. We could create a teacher here with a new teacher, and this is an integer, so I'll just say 3. So if I go ahead and I run this now, I'm going to get the teacher information. Let me actually go back in and fix the teacher information real quick, because it's major. I want expertise and years experience. Okay. So I'm going to go ahead and run this. I'll create the teacher. Doesn't exactly matter that I click the teacher because we haven't actually done anything with the radio buttons just yet on that, because we're not getting that information, and that will be the next thing that we cover after this. But we'll just do that with I can't spell my own name. I'm 134. And there we go. I have name is Greg Morris. I'm 134. My expertise is computer science, and I have 3 years experience in my 134 years of age. So that's just something that we can do. I have made the teacher. I didn't have to fill out the information because I have that hard coded at the moment. So just so you see that everything currently still works. But there's a couple of things that we might want to consider when dealing with a teacher as opposed to a student. So for instance, we might not necessarily want to have someone who's, say, like 10 years old being a teacher for us. We might not want to have someone who's 5 years old being a teacher for us. We probably want to make sure that our teachers are at least, say, like 18 years. But in our person class, we don't have anything other than they have to be at least 0 that is going to allow us to do this. So what we can do now is we can actually create a new method or a new way of setting our age to make sure that we don't have an age that's too high, or too low, I mean. So we can say like public int age, and we can get a getter, which is going to return this dot, well, I can return this dot age, because remember, age is private, so I can't return this dot age. And this dot underscore age is equal to value, but let me go back and do this real quick, because we wanted to do this if the age is only, let's see, if value is less than 18, we want to throw a new argument exception that says teachers must be at least 18. So there's our new exception that we're throwing if a value is under 18, but we still can't access this underscore age, and we can't really use this age because it's hiding another member. So what we want to do is, the first thing I'm going to talk about is access modifiers. So we talked a bit about access modifiers a while ago with public and private. And private means that it can only be accessed by the class in which it's written, which is what we have here. And then we have this public, which is one that can be accessed anywhere. Well, we don't want to set this as public because that would give people access to this value here, and we really don't want that, because then other programmers could willy-nilly change the age, and we have no way of verifying if we're getting the right information. So we have another one, and it's mentioned in the text, is called protected. Protected allows this class here, this person class, to access that age, and it allows any subclass to also access that age. So if we do this, now we can access this underscore age as a property and set it, because we have access to that property of the person class. But if I come back out here to form1.cs and I try to say like int number is assigned the value of p dot underscore age, I can't do it, because this class still doesn't have access to the underscore age property because it's not a child class. I could use capital A and access that property, but I can't access the underscore age property of the teacher class because it's still protected from the outside. Now the other thing, we still have this thing where we're hiding the method or hiding this property. And we don't necessarily want, or we do want to hide it because we're throwing a different exception now. We want to throw the exception if they're less than 18, not 0. So what we're going to do is we're actually going to put this keyword new in there. And basically what this is going to do is it's going to intentionally overwrite, so it's not even going to call this age anymore. So if we're checking for something here that we wanted to check for with a teacher, we're not going to be checking for it. This is going to completely override the other age member from the person class and check to make sure that the person is 18 or over. And that's really all that there is to that. So now I have this protected property that I can access with a child class, and I have a way that I can write a method or a property that can be accessed and not even bother with using the parent classes. You may not find a lot of uses for that, but it is something that is in there, and it's something that could be useful if you're wanting to create a new method. I suppose technically speaking, we could probably set this up as a virtual and then override it here, I'm thinking. I don't know, this is just a test. Okay, maybe we can't do that because we can't set this, int. There we go, that should probably work. Yeah, we could do it that way with a virtual and overriding, but I just kind of, and it would do about the same thing. I just wanted to kind of showcase how we could do that, and then also how we can use a protected property. So now we have all this together. We have our classes pretty much set now. Now we have to work on actually getting the information in the form to give us the information that we want. And how do we go about doing that but to start looking at our radio buttons, seeing what is checked, and coming up with information as appropriate. So we can do this in a number of different ways. So now let's go back and let's look at how we're going to actually create these persons with the information that we want and making sure that it's all good information. So the first thing I'm going to do is I'm going to come up here and I want to make sure in my isValidData method that I am checking the information that is there, that is the important information. So the first thing I'm going to do is I'm going to say if rad student checked. So if the student radio button is checked, that's the only thing I want to check right now, is that information. And we're going to say error append is present, and that is txt, which one is that? That's major dot text, and txt major dot tag dot toString, and error append is present, nope, not is valid email, is present, txt gpa.text, and txt gpa.tag text tag.toString. Okay, so if the student button is checked, then I want to make sure that the two values are there, and I want to make sure that since I'm doing GPA, I'm doing is decimal. So this is going to check if the student button is checked. It's going to check to make sure that all the information is there on the student. Now I'm going to do the exact same thing with the teacher. I don't want to take up more of your time if needs be, so I'm going to go ahead and just kind of skip the video forward just a little bit, and then I will just we'll kind of view everything all together, and we'll go from there. So give me just a minute. Okay, so here we go. I have the rest of it now. I have if the teacher button is clicked, checking for expertise, checking for the years, and then checking to see if it's an integer for the years. And that's pretty much it. And then if somehow, which should never happen because I have it set to default to the student button being checked, but somehow if a button is not checked, I'm going to throw a new exception that says somehow the radio button wasn't checked. And that exception should be caught by my try catch block down here. No, it probably won't be, because so I want to actually move try up here. And I'm going to move all my catches down here. That. Okay, let me see. There we go. There we go. And then if I do it this way, we're just going to kind of cut and paste. All of my statements should be lining up now. There we go. Okay. So sorry about that. Hopefully that wasn't too confusing. Basically, I'm going to put everything in my try catch block instead of putting the is valid data out, because is valid data can now throw an exception, and I want to make sure I catch that. So everything else should be good to go, I believe. There we go. Okay. So now that I have all of that together, and sorry about that little issue there. So now that I have all that together, what I want to do is I actually want to go ahead and create my person now the proper way. So we're going to create a person that I'm going to call P. And I'm not going to assign it the value of a new person or a new teacher or a new student, because at this time I don't know what I'm creating. So I have the valid data, so I know whichever way it goes, the valid data I have. And I'm actually going to change this up a little bit. We're going to throw a new exception. Just for fun, we'll keep throwing exceptions. Okay. And that'll give me an exception of all the information that I have. Okay. So if I have I now have my person P, and that person P is going to hold the information that I want. But I don't know if it's a student or teacher yet. So what I need to do again is check to see if the rad student is checked. If it is, I need to get the information from the appropriate text boxes and then create the student based on that. So what I want to do first is I want to get take the string major and assign the value of txt major.text. And then, whoa, that kind of really messed things up. GPA is going to be convert to decimal txt GPA.text. So I should not be able to get here without having valid data, so I'm not going to worry about using the try parse or anything here. So I'm going to convert that. Then we're going to do the else if, and I'm going to come back to this in just a minute. Else if rad teacher checked. String expertise is txt expertise.text, and int years is convert to int 32 txt years dot text. Okay, so I'm getting that information. So now I have my major, I have my GPA, or I have my expertise in years. I'm going to go ahead and create a little else here, where we're going to throw a new exception again. Again, this is only if there's no check boxes, so somehow radio button wasn't clicked. Question mark? Okay. So now I have those things together. I have my major GPA or I have my expertise in years. I need to go ahead and create my actual instance of each of these things. So I already have my P up here. And because I have my P up here, I can use the P in here and assign it the value of a new student, passing in the first name, last name, age, major, and GPA. So if you remember correctly, I said before that the inheritance relationship is an is-a relationship, which means every student is a person with regards to this particular program. That means I can create a generic person here, and then I can assign it the value of a new student. And there's a reason for this that I'll get to in just a second. So I have done that now. I've created a new student and put it into this person's space. And then what I can do is I can do the same thing here. Using the expertise and the years, and create my new teacher based on the expertise in years, and it's still going to fill this same person object. Now that's only set if the person, if the student is checked, then it's a student. If the teacher is checked, it's a teacher. So as long as you have one of those things checked, which you should, because there's at least one set by default, and you can never have two checked, you're going to create a person that's going to be referred to as P. This is the same thing as if we had done an integer. Let's just say we did an integer called number, and then here I set number was 5, and here number was 1. It's still assigning number a value based on if teacher or student is checked, and is going to fill this numbers space. It does the exact same thing. We're only using an object now and a class. So try not to get too confused about how that works. Let me go ahead and clear off these things. I don't really care if things aren't working right. Everything seems to be working fine to me. So now we don't need this. But now we also have this p.displayPerson and the p.toString. So if we go back and we think about it, when we wrote the teacher and we wrote the student, we overrode displayPerson and we overrode toString to make sure that the names would be the same. And the main reason for that is because we're using displayPerson here. If we didn't use displayPerson here, if we didn't have it defined in all 3 of our classes, we would have to call a specific method depending on which class we were defining. So we would have to have like the label output is p.showTeacher or p.showStudent. Well, that doesn't really make sense, and we can save on lines of code, especially once we get like bigger and larger programs. We can save on lines of code by just assigning an object to a generic open class like this, and then using the same method names. It just makes it a lot easier to write, a lot easier to maintain. And now whenever we want to change something, we can just go into the teacher class, let's just say, and we could change something about the teacher, and everything would be a lot easier for us to use. So let's go ahead and let's actually run this real quick, and let's just test and make sure that everything is working as it's supposed to be. So now everything is set up to actually take the information off the form. So if I try and show this now, I'm going to get an error. because that should not have happened. First student is checked. Object reference not set to an object. Okay. Kind of curious as to why I didn't catch the exception. It should be. System null reference exception. So did I not set a tag or something somewhere? Let me check my form. I did not set my tag. That was bad programming, Greg. Okay. That should all be working now. Okay. So now if I click show, okay. Unknown exception, section, first name is required field, last name is required field, age is required field, da 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 da. And it gives me all the information I have. Now, it puts it up here as an unknown exception. That's because I have it throwing a general exception. What I probably should go back and do real quick is have this, let's see, this here should probably go ahead and be an argument exception instead. Oh, not that one. It's in my statement down here. This should be an argument exception. In that way, it's not going to give me the unknown exception because I know what the exception is. So we're going to go and show argument exception. First name is required field, last name is required field, age is required field, age must be integer, blah, 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 blah. Okay, so everything appears now to be working as necessary, although I got a period before major that I want to clean up later. So now I can go ahead and I can fill in some information. We'll give myself an age of F, a major of computer, can't spell science, and a GPA of negative 0.4. Okay, I have an argument exception where age must be a valid integer value, so we'll do 1 point, I will be 297 now. And my GPA must be between 0.0 and 4.0, so we'll give myself I'll give myself a nice old 2.34 GPA. And now I can show that I have my display method here. I am Greg Morris, I'm 239, I'm a computer science major with 2.34 GPA. And in the CSV, the toString method of that, we have Greg Morris, 239, computer science, 2.342. So remember, the GPA that I have in the display is rounded to 2 places, and the GPA that I have in my CSV value is rounded to 3. Now if I go to the teacher, my expertise is in computers, and my years of experience is going to be 4.5. Okay, years must be a valid integer, so I put that in, and there we go. Everything now seems to be working as expected. So whenever I reset this, everything should clear. My errors come back, and everything is now pretty much exactly as I wanted it. But that, I think, hopefully goes to show how this all works together, how inheritance works. There's one other concept I just wanted to cover real quickly. This video is already over an hour long. I'm probably going to be cutting some of it out, so it'll probably still be a little over an hour long by the time I'm done. But the last thing that I want to cover real quick is the idea of abstraction in sealing a class. So an abstract class, when we write one, is a class that we cannot instantiate by itself. So if I define person as an abstract class, which I probably would in this case, if I define person as an abstract class, I can no longer go back in here to form and actually create a new person no matter what. So if I do Joe Snuffy 14, I can't do this because person is an abstract class. I can no longer instantiate an actual person. I can only inherit, or I can only instantiate subclasses of my abstract class. And another part of abstract classes is you could create a public abstract method, and let's just say Boolean that is here. When you define an abstract method, you cannot, you cannot actually define a, let me scroll that up a little bit. You cannot actually define a body to an abstract method. When you define an abstract method, you only define the method header. Once you define that method header, though, each class from there has to, each class that inherits that class must define its own version of that method. So we could do a public override, Boolean is here, and if we do it right now, it's going to throw a new not implemented exception, which we don't want. So we're just going to like return true for the time being. And same thing with the teacher, we need to also define that for any class that extends this person class, we need to override the isHere method and do something with it. Now, returning true isn't really going to do anything for us, but it defines the method and it gets us something in return. So that's what we call an abstract class and an abstract method. An abstract class, again, is one that we cannot directly instantiate. We cannot create a person unless it's a type of person. And then an abstract method, which I don't even think is covered by the text yet, if at all. An abstract method is something that we want in our classes, but in an abstract class, we don't have a definition for it. So like these up here, this public virtual string, display person, if we just wanted the other programmers to create a display person method without predefining a portion of it, we could do that. And then we would just define it as an abstract, and then anybody else that's using a subclass would have to actually define a display person method. The way we have it set up now is if I were to create another class based off person, I don't necessarily have to call or define display person because it will still give me the name and age, but I would have to define an isHere method. So those are two things called abstraction. And the last thing I'm going to touch on real briefly is called a sealed class. Now, sealed classes aren't something that I necessarily use very often, but basically a sealed class is a class that we define that cannot be inherited from. It cannot be extended. And for that we just add the word sealed. And basically if I were to go and try to extend, so let me go to student real quick, and if I wanted to extend teacher, it's not going to let me. Student cannot derive from sealed type teacher. So I cannot use teacher as a parent class because it is sealed. However, if I wanted to, I could further extend teacher now from student. If I wanted teacher to also have major and GPA, I could do that. Now that's not going to work with the form the way that I have it set up right now because I have the fields being locked at certain points and stuff like that. So I'd have to fix a lot of things to do it this way. But you can inherit class after class after class, and they're all going to get the properties of the classes before them. So for instance, teacher is inheriting person. Person inherited from the object class. The object class had the toString method. Now we overrode the toString method, but it was there for us. The person class overrode the toString method and was able to be used by the by the teacher class. So we can do that, and we could now, we can't do it now because we sealed the teacher, but with student, we could create a new student that we could say elementary student or high school student or college student. Those might look familiar from your assignment. You could create a student, a elementary student class. It could inherit the student class, and you would have access to the first name, last name, and age of the person. You would have access to the major and GPA of the student. And then for an elementary student, you might have, I don't know, favorite lunch food or something like that. I don't know, whatever it would be. You could inherit all of those things, and you do inherit all those things. And that's just one of the more powerful things really about object-oriented programming is how it works with inheritance, but it really takes some getting used to writing your classes and writing inheritance down so you could use it properly. Now there are a couple other things in here that the text goes over, like the different types and stuff like that. I'm not going to go too deep into that right now, but for instance, what we could do is you know, if we wanted to do something specific for a student and something different for a teacher, we could say something like if P get type is equal to, let me look up in the text real quick just so I can make sure. Is the type of, oops, clicked on the wrong screen. If P get type is type of student, then we could display the person, else we will use the get string, or the toString. So this is just something else that we could do real quick. Basically, if it's a student, we want to display the information. If it's a teacher, we're going to display the CSV values of it. And we'll just kind of showcase that real quick. And I think that'll probably be enough for this video. It's getting well over an hour now. And I really hate for these videos to be this long. I know I kind of drone on and ramble on sometimes, but I do think that the information is important. So we're going to go back with Gerg Morris, who's age 27. Major is going to be computer science, and GPA is 2.34. So when we show this student, we get that. When we go over here to the teacher, the expertise is computer science, and I've been doing it for 23 years. I didn't clear the box, and that's why we get it this way. But you can see how this one is using the information on CS in 23 years, and this one is using it on that. So, oh, I know why that happened, because I had plus equal to there. So we'll just run it one more real quick time just to show, and it should clear the box this time. And we're just going to do G, M, 32, C, 1 GPA, GM, 32, major is a C, GPA is a 1, and we'll do the same thing over there with a teacher, and then I just get the CSV value list. So that's just some things that you can do with that. That was touched on in the text, so I did want to mention it real quick. Try to get most of the topics from the text in this particular lesson, because the text actually has some pretty good information as far as inheritance on this one goes. So again, inheritance is something that can be kind of complicated to do properly. It takes some practice to really get to know exactly how everything works together. But I really think that if you focus on what's going on and just work on it, you should be able to figure this stuff out. But all in all, I think that's all for this week. This will probably be my last recording for this term unless something pops up. But all in all, I hope you guys have appreciated these videos if you've been watching them, and I hope they've been helpful. All in all, other than that, have a great week. Best of luck on your assignments, and best of luck in the future.